Hello. We'll do the problems on the morning session topics. Okay. Then after completion of the topics, we'll have only 3 topics. We'll complete that. Right. So here, write down this one. Simple. Only 2 or 3 formulas are there, but we have to concentrate on the question. Okay. For the any question, first of all, we have to write down the given data. What is the meaning of given data? Available data from the question. Whatever the data which is available in the question, that you have to write down as the given data. Okay. See, it is here. అది zoom చేయండి. Only question we require. Answer is not required. If it is zoom, zoom అంతేనా? An alternating current is given by I is equal to చిన్ననే చేయండి సార్. అది పోతుంది అక్కడ రైట్ సైడ్ లో కట్ అవుతుంది. ఇంకా కట్ అవుతుంది. An alternating current I is given by I is equal to 141.4 sin right side 4 sin 314t. Okay. Find the maximum value, frequency, time period and instantaneous value when time is 3 milliseconds. Okay. An alternating current I is given by I is equal to 141.4 sin 314 t. Find the maximum value, frequency, time period and instantaneous value when t is 3 milliseconds. It's very easy. What is the formula for I? For AC circuits, I is equal to Im sin omega t. So compare the general equation with a given equation. Okay, note down the values. What is the general formula? I is equal to Im sin omega t. An alternating current is given, I is given by I is equal to 141.4 sin 314t. Find the maximum value, frequency, time period and instantaneous value when time is 3 milliseconds. So everything is available in the question only. Only one formula we required. What is that formula? I is equal to Im sin omega t. That's all. What is the value? Compare that equation. I is equal to Im sin omega t. With respect to that one, I is equal to 141.4 sin 314t. So here omega is equal to 314. Yes. Im is equal to how much? Im is equal to 141.4. Yes. First question. Find the maximum value. Im is how much? First one. 141.4. There is no need of calculation. Directly compare the equation. Write down the value. First one is over. Second one. Frequency. What is the frequency formula we are having? Omega is equal to 2 pi f. Omega is equal to 2 pi f. Yes. First you note down that question. I will explain that one here. Everything is available in that equation. I is equal to 141.4 sin 314t. This is a long answer question. So what is the formula? Formula is equal to I is equal to Im sin omega t. Compare that equation with respect to this general equation and note down the obtain the different values. What is asking? First one is I maximum. Second one is F. Third one is instantaneous value. I instantaneous at t is equal to 3 milliseconds. Right. Okay. So here I is equal to 141. So compare this equation with respect to general equation. I am sin omega t. So from this, by comparing the above equation with respect to general equation, simple thing. I is equal to Im sin omega t. So Im is how much now? 141.4 amps. Okay. And second one is frequency. So frequency, how can we obtain frequency? So frequency is here omega t. Omega t. What is omega now? Omega is equal to 2 pi f t. Yes? T get cancelled. So omega is equal to 2 pi f. So f is equal to omega by 2 pi. So omega is how much? 314. 314 by 2 pi. How much you obtain? 50? Yes. So frequency is 50 hertz. Second one, f is equal to 50 hertz. So everything, it is available in the question only. It is available in the question only, but we have to compare the equation with respect to general equation. Okay. Next one. Instantaneous value at t is equal to 3 milliseconds. So here see, I is equal to 141.4 sin 314t. So we are not knows the value of t. Now he is asking about at t. 3 into 10 to the power of minus 3s seconds. Substitute this one in the equation. I is equal to 141.4 sin 314 into 3 into 10 to the power minus 3. Sin of this one, write down. 141.4 into sin 314 into 3 into 10 to the power minus 3. Milliseconds. Milli means 10 to the power minus 3 or 1 by 1000. 314 into 3 by 1000. That means you will get 0.9 something. 0 point something. So now I is equal to sine of something, you tell me. 141.4. 314 into 3 by 1000. Sine of that one. How much? Sine of that one. 0.016. Multiply 141 into 4 into 0.016. 2.32 amps. It is an instantaneous value at a at a at a time is equal to 3 milliseconds. So at 3 milliseconds, we are getting the value of current is 2.32. What is the maximum value? 141. Maximum value, that waveform. See, what is the meaning of this? General. General, what is the meaning here? It is a sine wave. It is omega t. So I have written this equation that I is equal to 141.4 sine 314t. So here it is 314t. Okay. So this is the maximum value. What is the maximum value? 141.4. So what is the time now? 314t. Okay. What is the frequency? What is the frequency? Frequency is, what is the other formula? 1 by time period. That is 50 Hz. Okay. This is from omega. Then instantaneous value. So at t is equal to milliseconds. What is the milliseconds? 314 into 3 milliseconds. The value is now how much? 2 points. So 2 point means it will come here. So here 3 milliseconds. For example, it is 314 into 3 milliseconds. The value is here now 2.32 amps. Okay. This is the value. So 3.2. That is the meaning. Okay, we are finding at 3 milliseconds. What is the value? This value, this y value we are finding. At maximum value, we are having 141. This is the meaning. The problem meaning is this one. So this wave is written as I is equal to Im sin omega t. Okay, so maximum value this one, frequency is this one, 1 by time period. Okay, and instantaneous value is this one. Second one, sir, note down. Second one, second. Otherwise, here also we are having. Hmm? Wait. They are asking 1 minute. No need of this circuit. This one waveform is not required actually, but just for understanding purpose. For exam, it is not required. 1 minute. 1 minute. Time period is there in the question. Huh? In the question, time period is there. Time period is nothing but one by frequency. Time period is asking time period. So time period is equal to 1 by frequency. That is 1 by 50. That is equal to 0.02 seconds for time period. After obtaining frequency, inverse of time period is equal to frequency. Second one, change. Huh? ఏంటమ్మా ఏమి ఇన్స్టంటేనియస్ వాల్యూ రాంగ్ నువ్వు తప్పు చేసావా సైన్ ఆఫ్ అవును ఎంత వచ్చింది మరి 114 114 కరెక్ట్ హౌ మచ్ దే సేయింగ్ ఇది మీరు చేయండి అమ్మా సైన్ ఏంటి 314 ఇంటూ 3 ఇంటూ 10⁻³ రేడియన్స్లో కన్వర్ట్ చేయి ఇట్ ఈస్ 114.35 amps 114 means here not this one here maybe here at 3 milliseconds this is the 114 okay రేడియన్స్లో కన్వర్ట్ చేయండి sin 314 into 3 into 10⁻³ convert into radians Okay. Second one, ఇది మీరే చెప్పారమ్మా, నేను కాదు. Second one, you note down. An alternating voltage is having the equation as V is equal to 167.8 sin 314t. Find the RMS voltage, frequency, and the instantaneous voltage when time is equal to 3.7 milliseconds. Over. So, over. Did you written question? Write down given data. What is the data given in the question? V value is given, V formula, V equation is given. So shift is given. Second question. An alternating voltage is having the equation as V is equal to 167.8 sin 314t. Shift. So here V is equal to, same you compare with the general equation. V is equal to 167.8 sin 314t. So V is equal to Vm sin omega t. Compare this equation. Okay. This is the given data. Compare with general equation. Okay. Given data. What we have to find out? We have to find out. First one is VRMS. Second one is frequency. Third one is instantaneous voltage, V instantaneous. At t is equal to 3.7 milliseconds. Simple. So what is the formula for VRMS? Vm by root 2. For alternating quantity, VRMS is Vm by root 2. Vm by root 2. So Vm is how much? 167.8 by root 2. 167.5 by 1.414. How much? 167.8 divided with 1.41. So the voltage is 118.67 volts. Yes. Now frequency. Frequency can be written as omega is equal to 2 pi f. F is equal to omega by 2 pi. So omega is given 314 by 2 pi. So this is always 50 only. 314 by 2 pi, 50 edge only. And instantaneous value same. V is equal to V instantaneous is equal to Vm 167.8 into sine 314 into, you take this one into radians, okay, 10 to the power minus 3. The value comes to be how much you got? How much? How much, Amma? Hmm? You take in consider by radians. 100? 1? How much? 167.8 into sine 314 into 3.7 into 10 to the power minus 3. 153 153.95 amps. Voltage. This is voltage. So instantaneous voltage is 153.95. So this is with respect to voltage equation and current equation for the morning session. Okay, you will get only these problems. General problem you have to compare. How many formulas we are having? Average value we are okay. We are not asking. Average formula is 2 Vm by pi. Average value 2 Vm by pi. VRMS Vm by root 2. Average value 2 Vm by pi. Hmm? Form factor is irrespective of the maximum value. Form factor is always 1.1. Okay, always 1.1. Form factor is equal to 1.1. There is no need of calculating. Okay, irrespective of the maximum value, minimum value, angle, time. Form factor of alternating quantity, irrespective of the equation, always form factor is 1.1. No need to calculate. And peak factor is 1.414. No need to calculate that too. Average value we will calculate, but is the question, okay, is not asked about that question. Average value is formula is 2 Vm by pi. 2 Vm by pi. Okay, that 2 Vm by pi means you have to take 22 by 7. Okay. Okay. So this is about for morning session problems. Now we'll discuss about When AC voltage is applied to resistor or resistance, what happens? Before that, so phasor. What is the meaning of phasor? What is the definition of phasor? Phase is over. Phase. What is the meaning of phase? Phase. The distance of the waveform with respect to x coordinate from the origin. This distance is known as phase. Phase difference is nothing but is a comparison between two waveforms. Okay, other waveform is here, for example. The different distance between this is nothing but phase different. Now, what is meant by phasor? So, phasor means, okay. So, for example, three phases are there. Three phases, four phases. Okay. So, for this, for every time it is difficult to draw the sine wave for the voltage waveform, and current waveform and power waveform. Okay, so it is very difficult to draw the sine waveform with respect to voltage and current and power. Now, instead of drawing the sine waveform, we will draw the phasor diagram. Phasor diagram or phasor. What is meant by phasor? Simply, I'm drawing here sine wave. See, okay. Now see, now I'm drawing the phasor. See, 0, 0. What is the angle here? 0. What is the angle here? 0. Okay. And now 90. 90. What is the value? Maximum value. What is the angle? 90. How can I draw the 90 for this? Can I shift like this? It is making 90 now. Yes. Then again it is 90. It is how much? 180. 180. 180 means this is shifting now again 180. Yes. This angle is 180 with respect to 0. 0 to here 90 and then 90. 180. Okay. Magnitude is 0. Okay. Then again 270. What is the value? Negative value. Negative value means again it is shifting again 90 degrees. Okay. 90, 180, 270. Okay, what is the value here? 0. What is the value? Plus 1. What is the value with respect to this one? Here also 0. Okay, 0. Here minus 1. Minus 1 here, see 270, 270, 180, 270. Now again 0. Again this is shifting here. See, instead of drawing one waveform, I am saying that one straight line having the length, having the length. How it is rotating from 0 to 360? It is rotating anti-clockwise. Yes, 0, 90, 180, 270, 360. How it is rotating? Okay. So, phasor is what is meant by phasor? Definition of phasor. Phasor is a straight line having the magnitude which will rotates anti-clockwise by the angle of 90 degrees. This is the definition. So instead of drawing a full waveform, I am simply say it is a sine waveform. It is a sine waveform, but I am saying it is a phasor, and I have to say it is rotating anti-clockwise direction with respect to 0 to 360 degrees, like this. It is rotating. So now you can say this is a phasor. This line is there now. This is a phasor. So phasor is nothing but which represents the angle and the magnitude. 0 degrees. 90 degrees means where you have to draw 90 degrees. 180 means where you have to draw 270 means as general graph representation. Okay. So x ordinate, y ordinate, okay, x left, y left, negative values. So it is plus magnitude, it is a minus magnitude with respect to x and, okay, first ordinate, second ordinate, third coordinate, fourth coordinate, like that. Same thing, okay. So this is about definition of phasor. Now, instead of drawing the waveform, we have to draw the phasor diagram for the any elements, any elements. Okay, how the power is there, how the voltage is there. Okay, now this is about phasor, the definition of phasor and that phasor how it will rotate. What is the meaning here? So the definition of phasor is a straight line which is having the magnitude which will rotate anti-clockwise direction by the angle of 90 degrees. Or you may write any by the angle of theta also you can write. Not 90, it may be angle of theta. Theta may be any value 0, 30, 40, 50, 90. But anti-clockwise it will rotate. This is very, very important. Okay, and which is having the straight line magnitude. Okay, so straight line magnitude rotating anti-clockwise direction. Okay, we are taking only 0, 90, 180, 270, 360. That's why we are using the word of 90. Okay, right. Now I am applying AC to resistor. What happens? AC to inductor. What happens? AC to capacitor. What happens? Okay, so here first one, three topics are there and one more small topic also there. Three topics. If we apply resistor to, okay, AC to resistor, AC to inductor, AC to capacitor, what happens? What happens in the circuit? Okay, how the power, what is mean by power factor? Okay, so these all we have to know for this. Okay, so AC applied to resistance or resistor. Okay, so here resistor is available. I am applying voltage. So AC voltage is nothing but Vm sin omega t. Okay, here what is the value? Resistor value R, which is measured in ohm. Okay, so V is equal to Vm sin omega t. So by the Ohm's law, resistor is came or represented. This element is invented by the Ohm's law only. Yes, I proportional to V. I is equal to IR is equal to V or V is equal to IR. Okay, I proportional to V or V proportional to I, V equal to IR. So the R is nothing but resistance. Resistor is invented by the resistance. Okay, so resistor is an element which follows the principle of resistance. What is meant by resistance? Resistance is nothing but the property of the material which opposes the flow of currents. That means the resistor element is invented by the formula of Ohm's law. So now we have to consider that Ohm's law. By the Ohm's law, V equal to IR. Okay. So this is the formula. What is I? V by R. What is I? V by R. Now V is equal to, you substitute here, Vm sin omega t is equal to IR. Okay. So now what is I now? Vm sin omega t by R. I is equal to Vm sin omega t by R. What is I with respect to AC? Im sin omega t. Yes? I is equal to Im sin omega t. So is equal to Vm sin omega t by R. So sin omega t will cancel. So now I is equal to Im is equal to Vm by R. So with respect to DC, I is equal to V by R. With respect to AC, I is equal to Vm by R. So this will become Im. Is there any difference is there with respect to DC and AC? There is no difference. So now here I is equal to Im sin omega t. V is equal to Vm sin omega t. Okay. So two equations are equal with respect to this. So I is equal to Vm by R. With respect to DC circuit also same. Okay. So when compared to both equations, there is no change in angle. Is there any change in angle is there? Sin omega t, sin omega t. Only constants are different. I is equal to Im, V is equal to Vm. Okay. Im is equal to Vm by R. There is no change in angle. So with respect to this, what is the waveform now? So Vm I am writing Vm. So this is the Vm waveform. Vm voltage waveform. Okay. Now Im waveform I have to draw. I value. I is equal to Im sin omega t. I is equal to Im sin omega t. So Im is equal to Vm by R. Im is equal to Vm by R. So this Vm is decreasing now with respect to resistor. So here, so this is nothing but Im. So this Im value is Vm by R. How we are got this magnitude? Vm by R. So Vm by R means the which is less than Vm. So that's why I have drawn the magnitude as like this. Is there any phase? What is the phase difference between them now? What is the phase difference between them? Both waveforms are starting with respect to 0 only. Origin only. What is the phase difference? Pi 2 minus pi 1 is equal to 0 minus 0. How much? 0. Okay. So pi is how much? 0. Okay. Now, what is power factor? What is power factor? What is the formula? Cos pi. What is cos 0? What is cos 0? 1. So power factor of resistive network is unity. That means 1. It is called 1 or unity. For resistor, always the power factor, only resistor. A circuit which consisting of only resistor, the power factor is 1. The question may come like this. Explain about resistor connected to AC supply. You have to write down this one. What is mean by this? What is mean by this? So with respect to, so here what is meant by R? R is nothing but resistance of the circuit or resistor. Okay. If we draw the phasor diagram, how can we draw the phasor diagram for this resistance circuit? Okay. See, voltage, phasor diagram. Voltage is higher, voltage value is higher, or current value is higher. Voltage value is higher or current value is higher. Voltage value is higher. So that's why you have to write down a big line for voltage. It is Im. Okay. So this is the phasor diagram. It is waveform. Which is easy to draw? Only phasor diagram is easy to draw. That's why instead of drawing this, we'll draw this one for the any circuits. Phasor diagram representation is important. Why? Because it is difficult to draw the diagram, this waveform. You understand how we got this one? Same, phase means 0. Okay. So Vm by R, 20 by something, which is less than 20. So that's why I have drawn the less value. So in this, you have to remember the formulas. Because of it resistor, okay, there is no confusion about the formulas, only Im. What is mean by Im? Im is nothing but Vm by R. Okay, if you know Vm value, divide with the resistor, you will get Im. Right? Now, AC applied to the inductor. AC is applied to the inductor. What happens? From this derivation also, that we are having different type of formulas. Okay, you will get the problem. You will get the problem. Kindly remember the equations. V is equal to Vm sin omega t, I is equal to Im sin omega t, and Im is equal to Vm by R. Im is equal to Vm by R. What is the power factor of this circuit? What is the value of power factor? 1. Okay. Even though value is Vm sin omega t, I is equal to Im sin omega t. What is the value? Im, Vm. Vm have not given any value. 141 sin omega t or something current is 40 sin omega t. Irrespective of the values of this equation, Vm, what is the power factor? Unity. This one is irrespective of the value of the equation to the resistor. Resistor value also any value. Resistor value 100, 10,000. What is the power factor? 1 only. Okay. So next one is AC applied to the inductor or inductance. Applied to inductance or inductor. So inductor is, so I am applying AC. AC is nothing but Vm sin omega t. Okay. What is the formula for voltage in inductor? What is the formula for voltage in inductor? V is equal to L di by dt. Yes. From the Ohm's law, for the resistor we have written V is equal to IR. Same here also, V is equal to L dA by dt. Okay, now what is V now with respect to AC circuit? Vm sin omega t is equal to L di by dt. Okay, now see I am bringing here L di, writing this right side, left side, left side, right side. L di is equal to Vm sin L di by dt is equal to Vm sin omega t. Okay, now L di is equal to Vm sin omega t dt. Yes, only with respect to time, not omega t, with respect to time. What is the equation? V is equal to L di by dt. Simple mathematics. V is equal to Vm sin omega t. V is equal to L di by dt. This is the formula for with respect to inductor. So V is equal to L di by dt means what is V in AC circuits? Vm sin omega t. Vm sin omega t is equal to L di by dt. And okay, simple mathematics. L di by dt left side, I am bringing this one right side. L di by dt is equal to Vm sin omega t. Okay, we require I equation. Now L dt I am bringing there. So L di is equal to omega, so Vm sin omega t dt. And now di is equal to Vm by L. Yes, Vm by L sin omega t dt. Yes, di is equal to Vm by L sin omega t dt. Okay, now integrating on both sides. Integrating on both sides. What happens? Integral di is equal to integral Vm by L sin omega sin omega t dt. Okay, so it will become now integral differentiation. Okay, get cancel. You will get I is equal to this Vm by L means constant. I am bringing outside L. So integral sin omega t dt, not d omega t, dt. So integration of sin omega t with respect to dt. Integration of sin minus cos. So Vm by L minus cos omega t by omega. By we will get, why? Because with we are integrating with respect to d. We are integrating with respect to d, not omega t. Not d omega t, we are integrating with respect to d. Okay? Right, we will get cos omega t by t. Yes? Sin omega t is nothing but cos omega t. By omega you will get. Okay? Right. Now, omega is constant. Yes. So, I is equal to what? Vm by omega L minus cos omega t. Okay. So how can I write this minus cos omega t in terms of sine? Some sine 90 plus theta, 90 minus theta, or theta minus 90, like that we'll write now. How can we write minus cos omega t? So here I is equal to Vm by omega L, okay, sine omega t minus pi by 2. Okay. So here from this you can write now I is equal to I into omega L is equal to Vm sin omega t minus pi by 2. Okay, or you write down same only. No, don't write this one. I is equal to Vm by omega L sin omega t minus pi by 2. Okay, so what is V now? What is Vm? V is equal to Vm sin omega t. Now what is I? I is equal to, now here in place of this I am writing Im sin omega t minus pi by 2. By comparing both equations, what you observed here? Vm, Im, sin omega t minus 90. Okay, so it means current lags by 90 degrees to voltage. Okay, so here, so in the inductive circuit, whenever a inductor is connected to AC circuit, how the waveform of voltage and current? Voltage waveform move fastly, current waveform move slowly by 90 degrees. By 90 degrees. Okay. How can we draw this phasor diagram and how can we draw the uh, waveform for this inductive circuit? Phasor diagram is easy. Current lags by voltage by 90 degrees. Okay. So phasor diagram is easy. First I am drawing phasor diagram. Phasor diagram. Okay. This is voltage. Current lags by 90 degrees. This is I. Okay. Current lags by 90 degrees. Current lags by 90 degrees. So phasor diagram is easy to draw. But waveform we'll write down. After this we will draw the waveform. Okay. We'll draw the waveform. What is the meaning of lagging? Lagging means late. Okay. Which one is late? Current waveform is lags by 90 degrees with respect to voltage waveform. Do you return this? What is the value here? It is L value, L. Draw the waveform now. Draw the waveform for this one. V is equal to Vm sin omega t. First, I think you know. How can you write down? V is equal to Vm sin omega t. Right. This is Vm. V is equal to Vm sin omega t. Now I have to draw the current waveform. How can I draw the current waveform? What is the angle between them? 90 degrees. Yes, angle between them 90 degrees. So here 0. Where can I draw this waveform now? Voltage waveform is fast or current waveform is fast? Voltage waveform is fast. So after this, here see. So it is current waveform. It is Im value. So here how much? What is the angle between them? Pi by 2. So it is called lagging. Lagging. So with respect to x-axis, voltage waveform is first. With respect to x-axis, voltage waveform is first. What is the magnitude? Vm is the magnitude. Okay. Vm is the magnitude. Next, by 90 degrees. By 90 degrees. Yes, it is 90 degrees. Current waveform. What is the magnitude? Im. This is the waveform. Okay. This waveform and phasor diagram is you have to write down in the exam. Okay. Explain about the whenever inductor connected to the AC alternating quantity. You have to write down this one. Okay. Phasor diagram. What are the two equations? Voltage equation and current equation. What is Im here now? What is Im? Im is equal to Vm by omega L. Okay. What is omega? 2 pi f. 2 pi f. Okay. Now AC alternating quantity applied to the capacitor. Okay. We'll write down that one. Capacitor. So here what is the formula? V is equal to Vm sin omega t. We are applied it's a capacitor. Okay. So V is equal to Vm sin omega t. Okay. So here V is equal to Vm sin omega t. What is the formula? Current in a capacitor. What is the formula? Or voltage across the capacitor. What is the formula? What is the formula? I is equal to formula. No, with respect to capacitor, general formula. V is equal to L di by dt. Yes, I is equal to C dV by dt. Okay, I is equal to C dV by dt. This is a formula. V is equal to L di by dt. I is equal in capacitor. I is equal to C dV by dt. Okay. Now you write down here I is equal to substitute here C d differentiate with respect to Vm sin omega t with respect to dt. So Vm is constant. So here I is equal to C Vm differentiation of sin omega t with respect to dt. -90 degree. What is the phasor diagram now? What is the phasor diagram? Phasor diagram is, now we are taking voltage as a reference. Okay, so can I write this one in terms of like this? I is equal to Im sin omega t plus pi by 2. What is Im from this? Im is equal to omega c Vm. Okay, Im. So V. Current leads by 90 degrees. Leading means positive value. Lags means negative value. Okay. This is the phasor diagram. Now, how can we write down the waveform? How can we draw the waveform? You simple, in previous diagram, you simple replace voltage and current. Replace the voltage with current with voltage. You will get the diagram. Same diagram, replace V. In place of V, you write down I. In place of I, you write down V. Okay. Okay. So first we have taken this one as a voltage. Now you take this one as a current. After this, okay, voltage. This is a voltage. So voltage magnitude is more. So this is voltage Vm. This is Im. So which one is first now? Which one is first? Current waveform is first. Voltage is late by 90 degrees. So here current leads by voltage. So leads means leading first by 90 degrees. So this is the waveform. So because the current value is less, or current value is depending upon the formula, you write down like this. Okay. From this, when we are applying inductor to the AC and capacitor to AC, what are the different formulas you obtained? What are the different formulas you are obtained? V is equal to Vm sin omega t. I is equal to In sin omega t minus 90 degrees for inductor. Here V is equal to Vm sin omega t. I is equal to Im sin omega t plus 90. Okay. And what is Im now? Im in inductor. Im in inductor. Vm by omega L. What is Im in capacitor? Vm into omega C. These four formulas are very, very important. Okay. Can I erase? V is equal to Vm. So here for the inductor, what is the formula for inductor? V is equal to Vm sin omega t. I is equal to Im sin omega t minus pi by 2. Okay, from this Im is equal to Vm by omega L. This is for inductor. For capacitor, V is equal to Vm sin omega t and I is equal to Im sin omega t plus 90 degrees and Im is equal to omega c into Vm. Okay. So here see omega L with respect to when we are writing Im and Vm, we got 1 by omega L. Okay. And here with respect to Vm Im, we got omega c. So these are called, see here you can call this term as inductive reactance. This is called capacitive reactance. Okay, capacitive reactance. See here Vm is equal to Im omega L. Yes, for this formula. Here Im is equal to omega c Vm. Okay, so here I am writing now XL. Vm is equal to Im into XL. Here Vm is equal to Im by not Im by Im into XC. Okay, what is XL here? XL is equal to omega L. What is XC? XC is 1 by omega C. So these two terms are called inductive reactance and capacitive reactance. XL is equal to omega L, XC is equal to 1 by omega C. So these are called inductive reactance and capacitive reactance. Okay. Now, okay, impedance. Impedance will write always as Z is equal to R plus or minus Jx. Okay. Otherwise, Z is equal to R plus JXL or Z is equal to R minus JXC. Okay. So what is mean by impedance with respect to AC circuit? With respect to AC circuit, okay, whenever resistor inductor takes place, whenever resistor capacitor will takes place, okay, we are having one more term called reactance. What is X here? X is nothing but reactance. Simple. What is mean by impedance? Impedance is a impedance means same meaning with respect to resistance. What is mean by resistance? What is mean by resistance? Resistance is a property of the material which opposes the flow of electrons. In the same way, what is meant by impedance? Impedance means it is a property of material, same property of material which does not allow to flow current in circuit. What is the difference then? Whenever AC supply applied, only that is the difference. Only this one difference. So in AC circuits we'll call it as Z. In DC circuit we'll call it as resistor. So because of we are having the inductive effect or capacitive effect, okay, the term we derived as Z. Z is equal to R plus JXL or Z is equal to R minus JXC. Okay. So these formulas with respect to problems are important, and this one also. Okay. So we'll do the problems on this now. We'll do the problems on this. Okay. Okay. We'll do the problems. Hello. We'll do the problems now. Okay. Madam, who will operate this? పిలవండి అతను పిలవండి. Meanwhile, you note down the problem. Kindly note down. An AC circuit consists of a pure resistor An AC circuit consists of pure resistor of 10 ohm. An AC circuit consists of a pure resistor of 10 ohm and is connected across an AC supply of 230 voltage 50 hertz. Calculate, I repeat, no need to worry. Calculate current. Second one, power consumed. Third one, phase angle. Fourth one, voltage equation and current equation. Voltage equation and current equation. So it is very, very easy. It's look like 4 lines, but it is very, very easy. I repeat, an AC circuit consists of a pure resistor of 10 ohm and is connected across an AC supply of 230 voltage, comma 50 hertz. Calculate current, calculate power consumed. Third one, phase angle. Fourth one, voltage and current equation. Voltage and current equation. It is a 14th problem. 14th. అందులో లేదా వేరే ప్రాబ్లమ్స్ అని ఉంది చూడండి, వేరేది. 14th file is there, serial number 14. Now you calculate, everything is already written. An AC circuit, same problem. Already రాసినారు. After that we'll do that one here. ఇక్కడ చేద్దాం at the end. ఇక్కడ you display this one, shift. So here the question is an AC circuit consisting of pure resistance. So given data you write down. Given data R is equal to 10 ohm is connected across a supply of V is equal to 230, frequency 50. First one, what we have to find out? Current. Second one, power. Third one, phase angle, pi. Fourth one, voltage equation and a current equation. Okay. So what is the formula with respect to this? What is the formula? Resistive, when AC circuit, when AC is applied to resistor, what are the formulas you are having? Kindly remember that formulas. Okay. V is equal to Vm sin omega t. I is equal to Im sin omega t. Okay. So what is Im? Im is equal to Vm by R. Okay. Now R. I is equal to V by R. Okay. See here V is equal to 230 volts. What is the value? This one 230. What is this one? It Vm? No, it is VRMS. It is VRMS. Okay. We require now current I is equal V by R or Im is equal Vm by R. Okay. So you require to find out Im. What is Im? Im is equal V by M by Vm by R. What is Vm? What is Vm? What is the relation between VRMS, Vm by root 2. What is Vm now? Vm is equal to VRMS into root 2. VRMS into root 2. Okay. So what is VRMS? 230 into root 2. How much? 230 into root 2. How much? Huh? 325.2 is Vm. Now find out Im. Find out Im. Huh? 325.2 by R. R is how much? 10. How much? 32.52. This is the maximum value. 32.52 is the maximum value. So for the resistive network, whether you are saying maximum value or maximum value, it is same only. I is equal V by R or V is equal to IR for the AC, for the resistive network. So you can write this current as 32.52. Okay. Now right. What is power now? Power is nothing but Vm Im. Vm Im. Vm is how much? 325.2 into Im. 32.52. Huh? 10575 watts. Huh? Okay, that is okay. Watts. Or you can write down 230 into 32 also. That is also correct. Phase angle always for the resistive network 0 degrees only. What is the voltage equation? Vm sin omega t. Omega is how much? 2 pi f. So 314 t. I is equal to Im sin 314t. What is Vm? You write down Vm is V is equal to 325.2 sin 314t. I is equal to 32.5 sin 314t. So these are the equations with respect to voltage and current. These are the equations of voltage and current. Okay. Here we have taken maximum values. Maximum values. You can take RMS values also. IRMS is equal to IRMS is equal to Im by root 2. Okay. This is Im value. Okay. You can find out IRMS also. IRMS is equal to Im by root 2. 32.52 by root 2 also you can do. This is the maximum value. This is the RMS value. So always we have to mention RMS values only. Okay. So this is also VM and IM. Convert into VRMS. Okay. Or divide with root 2 into root 2. How much? 2. Divide with 2. 5, 500 you will get. 500 watts you will get. So 32.52 root 2 is the IRMS. This is okay, nothing will happen. Power is equal Vm Im. So if you convert this one into root 2, it will 2. By 2 you write down that is 500. 500, 5000. 5290 watts. Okay? Why? Because we have to convert into RMS. VRMS is equal to Vm by root 2. IRMS is equal to Im by root 2. So Vm by root 2 into by Im by root 2. Root 2 will get cancelled 2. So Vm into Im by 2 is nothing but wattage. So always you have to consider RMS value only. Okay, for any formula you have to consider RMS value only. Next one. Next one. A pure a pure inductive coil allows a pure inductive coil allows a current of 10 amps. A current of 10 amps to flow from a 230 volts 50 edge supply. First one, find inductive reactance